In previous video lecture, we saw about perceptron, what are the different formula for perceptron, and we are about to discuss an example applying perceptron to the AND function. So we will take input by input. First we will take the first input. So now what are the truth table items that we need to actually write down first, right? First you have the input, then you have net is y underscore in and out is 0, target out, that is out, then target, that is the expected output, then the weight change, that is delta w, then weight updation, that is w of new and b of new. So first we will take 1 we are going from back to front, back to top. So we will take 1 and bias is 1. So we all know the formula for net y underscore in, that is b plus sigma xi wi. So b plus, here we have two inputs, so x1 w1 plus x2 w2. Initially we initialize w as 0. So we get value as y underscore in value as, that is net value as 0, and then we need to find out out value. So for finding out, we have to compare y underscore in result with the theta, that is 0.2. So if we do that comparison, we will get out is 0. And target is the expected outcome. For 1 input, the AND gate output is 1. So when we compare out and 1, right, they are not same. It means that there is an error. Then we need to do the weight change, right? If there is an error, definitely there is going to be the weight change. Weight change is whatever the target value is there, that has to be written for the weight change if error has occurred. Okay, then you need to update w1. For updating w1, you need to use the formula of w1 of new, right? Then for updating w2, you are going to use the formula of w2 of new, and then you need to update the bias b of new, right? This is the first procedure. Now we need to draw the separating lines. So separating lines will tell what is the variation between input and the output x, that is for in different inputs x1 x2. So for drawing the separating line, you need to have the equation. So there will be two equations. How to form these equations we will see now. Okay, now x1 plus x2 plus 1, because x1 x2 are 1, so you need to write down x1 plus x2 plus 1 is equal to theta, that is 0.2, and another equation you need to write it with minus 0.2. Okay, so it may, now you need to draw the separating line from these equations. Now question comes, how to draw line from the equation, right? So before you draw the line, means you need to form the graph. So out of x1 x2, which is going to be x-axis, which is going to be y-axis. Okay, so x1 is in the x-axis and x2 is the y-axis, because x1 is the independent variable, x2 is the dependent variable. Now to draw the line, we need to first, what we need to do is keep x2 on one side and push x1 to the right hand side, and you put different values of x1 and you plot x2. Say for substitute x1 as 0 1 2 3 4 5 and then plot x2. Likewise take also the negative value, substitute x1 as -1 -2 -3 -4 -5 and then plot x2, and if you join all the dots, you are going to get the separating lines. Okay, if you do so, you will be getting the separating line like this. After plotting the equations of two lines, you are going to get the lines like this, and note that x-axis is x1 and y-axis is x2. So this is for first input. Now you know there are 4 inputs, right, in AND gate, 2 input AND gate. Now you need to do it for the second input. 1 0 1, you are going to get, you are getting net formula as 2, out as 1, target as -1, Now compare output and the target. Of course, output and target are not same, so there is error. If there is error, that is output not equal to target, you need to do the delta W updation. Delta W means whatever the target value is there, you write it. So you write it as -1 for delta W for x1 and 0 for x2 because it is 0 input, so you write it as 0. And then for updating for bias, you write it as target, that is -1. Okay, and then again you need to do the updation of weights W1 W2 bias. Now coming to the separating lines, so now you need to draw the separating lines. So now here x2 is 0, x2 is 0 and x1 is 1. So since x2 is 0, okay, so x2 is in the 0 point. So for 0 point you are going to x1 is only 1, so that is x-axis. In x-axis x1 is 1 for 1, so x2 is going to be 0.2. So if you plot x2 0.2 and minus 0.2, you are going to get the separating lines like this. So what is the significance of the separating line? Separating line tells, one line tells which it is like greater than 0.2, another line tells it is less than -0.2. It is a we can say a limit for the data to occur, for samples to occur. It is the limit. These lines are the limit. So likewise you need to apply for the different inputs, third input, fourth input, and you need to continue this process till you get output equal to the target, right? You should keep on continuing this process. See, now this is after third epoch. So after third epoch also we can see that there is the difference between out and target, means there is an error in the third epoch. You can see in this picture. So -1 is correct, no error. 0 -1, there is an error, right? -1 no error, -1 still there is error, so it has to be continued. So like this we continue, go to the 10th epoch. So you can see in the 10th epoch, okay, we have reached 10th epoch, and here output is equal to target for all the inputs. You can see in this truth table y is equal to t. At this time you need to actually stop. Okay, then you need to draw the separating lines. So this is about the perceptron, and in the next video we will see about another neural network. Thank you.